Hello everybody, welcome to tutorial 5, and in today's tutorial we're going to be using Ladybug, as we've downloaded in the previous tutorial, to create a direct sun hours analysis. So we want to go ahead and download an EPW file that can be found in this website, and to get to this website it's just to write Ladybug EPW. The first result is the one we're looking for, and it gives you data sets all around the world. Now, we want a data set from Melbourne, Victoria, obviously, and we can go down to Melbourne, and for me I've used this blue dot over here in Northern CBD, and all we have to do is download it from this link here. So I've already done that, and then extract the files and use the files inside. So the one we're looking for is this one here, .epw. A way to import it into Grasshopper is to use a file path container. So that's this one here, and then we can set one existing file, and EPW is the one we're looking for. Now to visualize this data set is to go to import, LB import EPW, drag that file inside, and now we have that imported into Grasshopper. And then to visualize this data, we'll have to go and get the direct sun hours, which should be, direct sun path, because that's what the data set that we need, the component that we need. Plugin location, then we can pick an analysis period. There we go. So we want all year. We're going to go ahead with the first month of the year, the 12th month of the year is our end result. And then we want to obviously create the direct sun hours, so we can go ahead and type in direct sun hours on the canvas. Now vectors goes into vectors, and now we need the geometry that we're going to analyze. So for that purpose, we're going to select all the buildings that we want to analyze, create a mesh component, because that's what they are, a mesh container, sorry. That's the geometry we want to analyze, and it's also going to be the context because they're the surroundings. And then we want to create a grid size. I'm going to go ahead 5, and a boolean toggle to run the component. Now before we all do that, let's put the sun path inside of the center of our site. So the way to do that is to create a point container. I've already made points into Rhino, and I'm going to use this point here. Select one or set one point. That point can be the center point of the sun path, and as you can see it's moved right now. I can go ahead and hide that point. I don't need this point either. And then because it's a bit smaller, we need to scale up the sun path. So I'm going to go ahead and choose 25, maybe times it by 25. Oh, there we go, perfect. And that's our sun path. The period is going to be through the hoist to hoist, and as you can see it's created all those points. So that's each individual point is a hour during the year of where the sun would be. Now we can go ahead yeah, now we can go ahead and analyze it. So what we have to do is double click the boolean toggle. Now this may take a while for Rhino to render all the data, but we'll just wait for that now. Yep, Yep, so as we can see, it's been rendered. It's a bit laggy as there's so much data that's been loaded. However, we have the relevant data that we need. And as we can see, we get a maximum of 4,420 hours throughout the year of sunlight, direct sunlight, and a minimum of 0. Yeah. So yeah, we can see that all these are rendered, and if we take this building for example, you can see where it's all the sunlight's coming in. And thank you for watching this tutorial.